For this last type of example, let's look at one that's a little bit more of a word problem. This one says that we have the maximum load of a beam, and how much it can support varies jointly with the width of the beam and the square of its depth, but it varies inversely as the length of the beam. So some of that initial information there is really just giving us a formula for how everything is connected. So we'll definitely set up an equation that models that situation. All right, let's continue on. Assuming that a beam that is 3 feet wide, 2 feet deep, 30 feet long, can support 84 pounds, what is the maximum load a similar beam can support if it is 2 feet wide, 5 feet deep, and 100 feet long? Okay, a lot of information floating around there. Let's start off by seeing if we can set up this formula. So the maximum load that a beam can support varies jointly as the width of the beam and the square of its depth. So since this is jointly, I'm talking about K times its width times the square of its depth, or D squared. Okay, now it varies inversely with the length, so I'll put the length on the bottom. So this part right here is our formula that we'll end up using. Alright, now assuming that a beam is 3 feet wide, 2 feet deep, and 30 feet long, can support 84 pounds, let's use that to figure out our unknown constant sitting right here, that K. So I know it can support 84 pounds, don't know K. Let's see, 3 feet wide, so we'll put that in for our width, 2 feet deep, and it is 30 long. So the only unknown is that K. Let's go ahead and simplify just a little bit in here. So I have 3 times 2 squared, and 2 squared is 4, so 12. I can get that K a little bit more by itself if I multiply both sides by 30. So 84 times 30. Let's go ahead and put those together. Let's see, that'd be 2,520. All right, and now divide both sides by 12. So that's where we've actually been able to figure out what that unknown constant is. Now that I have that, I can go back to the original formula. So M equals 210W times D squared all over L. Now we'll use this new formula to figure out a little bit of known information, or more new information. We'll look at it for the other beam where we're looking for its maximum load if we know its width, its depth, and its length. So let's give that a try. So that formula we developed was its maximum load equals 210 times the width times D squared all over length. All right, now let's put in our information. For this new beam, its width is 2 feet, and its depth is 5. It also has a length of 100. So as soon as we simplify all that, we'll be able to figure out what its maximum load should be. All right, so 210 times 2 would be 420, times 25, all divided by 10. Oh, divided by 100. All right. Let's do some simplifying here. So 420 times 25, 10500 all over 100. And it looks like this reduces to 105. So this new beam can support a maximum of 105 pounds. So being able to recognize various different types of variation and combine them all together is essential for some more complicated problems. Remember that if you have those nice formulas, then you can really go through 3 steps. 1, build the formula or equation that models the situation, solve for your unknown K, and then finally use some new information to figure out some more information about the problem. Thank you for watching Educator.com.